Okay. Whoa. There's a mic here next to me. Maybe that's okay. Okay, is everybody hearing me all right? I'm recovering from a cold, so my voice might be a little bit lower and weaker, so let me know if you don't hear anything. I try to speak louder. Excuses. I was just actually drinking, yeah. Okay. So I'm Juri, Signature Ventures. I'm a partner at the company, and just as a very short disclaimer, we're actually investors in those two handsome young men on the right side. So just want to make that clear. I will start off by very simply introducing all of you guys. If you just start maybe with David, I mean, you just talked a little bit already, but introduce yourself and the company very briefly, please.
Sure. So yeah, I'm David, CEO of Valory. Valory is co-contributor to Olas. With Olas, we ultimately want to give everyone an autonomous agent that does useful things for them. Ultimately, they should be as generic as possible, help you become wealthier, healthier, better off. Today, they're very scoped applications.
Hey everyone, I'm Don. I'm the co-founder and CEO of Nevermined. We're building the decentralized AI payments protocol. Our thesis is predicated on the concept of AI commerce, which is the idea that we're witnessing the rise of a new consumer that will manifest as trillions of AI agents that are going to change commerce forever. So in response, we're building the PayPal of AI to be the engine to power AI commerce.
Hey folks, I'm Jarrod Barnes, head of founder success at Near. What that means is I get the opportunity to work with all of our amazing founders building on Near. Ooh, sorry. One of them being Don. So very excited to share a little bit about what we are building both internally in our own products and our broader AI ecosystem.
Hi, my name is Levi. I'm the founder of Coophive. So we're building a generic machine actionable marketplaces. So marketplaces that are built for machines and not for humans, because that's who's going to be doing most of the economic activity in the future. Is that all right? Yeah, so then using those marketplaces, we can start designing composable games where these agents can play and cooperate and compete to achieve larger goals.
Okay, thanks you guys. So maybe start a little bit light and a little bit general about multi-agent systems. Why can't we just go to a GPT-4 or GPT-5 maybe in the future and just use them, right? Generally as a whole monolithic structure, why do we need multiple agents to actually do the work for us?
Yeah, happy to start. I feel like we have a lot of issues here. Should we cut it down to like just one microphone? Just practically speaking. Should we just go with one microphone? I feel like... All right. Okay, so back to the question at hand. So multi-agent systems. Well, firstly, if we think about, let's imagine there's like a very capable general purpose technology beyond current ChatGPT capabilities that can function as an agent, because that's another thing, like a model isn't an agent yet, so you need something else. Let's imagine we have that, then naturally you have a question of like, in any economic like competitive environment, like you can use the thing for one thing and then it's used for that thing. So you then can't use it for the other. And basically, what I think will happen is that we'll find, and we already see this with like the way models are used and agents are used, that you have high degrees of specialization. You have basically economies of scale around like specific use cases where models and agents specialize in doing one thing very well, even if in principle they're capable of doing many things well. And so if that's the case, then you immediately have the situation where you have multiple agents focusing on different things, and the question arises, can we have like sort of trade between them and will they use each other and so on? And the answer will be yes. So that's the kind of competitive side where you have like agents in an economy sort of arranged. The other way to think about agents is that you basically in a given application just have sort of multiple agents and the application as a whole functions as a multi-agent system. The benefit of this can often be that you basically just get better results. There's a lot of like scientific research which shows that.
Just maybe take a step back. So a multi-agent system is it's a synthetic environment that has more than one intelligent agent. And an intelligent agent is it's an agent that can perceive its environment and take those inputs and then perform behavioral tasks on those inputs, usually in a autonomous or at least a semi-autonomous fashion. So to be slightly pedantic on the question, I don't think the GPT has that ability to perform behavioral tasks in the way that a AI agent does.
Yeah, just to simply put it, it expands the scope of problems that you can solve, right? Models are incredibly powerful, but they give you an output, right? We have not necessarily reached the point of agentic models yet, fully in production. Agents enable you to take action. That's a big part of what we get excited about, and probably going to talk a little bit more about, but expanding the scope of surface area you can touch and problems you can solve.
Yeah, so is this on? Yeah. Basically, there's like many different like levels of how you can model where agents are at in like in a particular environment. So you could imagine if let's say like collective intelligence on a biological level is a multi-agent system, right? So ant colonies, beehives, etc., birds, flocks of birds. These are all intelligent systems, and you have all of these like animals interacting with each other and forming a higher collective intelligence. I think that's really like the kind of big picture core outcome from multi-agent systems, is that you have at least one intelligent agents that are interacting in the same environment, and when they're doing that, there are properties that emerge that are where the sum is basically greater than the individual pieces summed together. The whole is greater than the sum of its parts.
Yeah, makes sense. And if you just keep a little bit still with the multi-agent systems, you can imagine having multiple agents. Again, everybody has their own specific model, right? But it's still within a framework. Let's say if I go to Relevance AI right now, I can just combine a workforce of different agents. So one of them will be transcribing me a video, the other one will be writing me a blog post based on the transcript. So there'll be all these kind of things, right? And they'll be collaboratively doing something for me. But if I, for example, go on the definition, I just picked it up from the Olas website, one of the things that's mentioned is that multi-agent systems are inherently decentralized. Each of the agents pursues its own objectives, and as a result, conflicts of interest are expected to arise. So they have to be resolved as well. So why is it that in the, let's say, agent systems or multiple agent systems in crypto, we have... Thank you. Okay, does it work? Okay. So why is it that in this crypto space, we kind of have this acknowledgement or maybe realization that their agents might not collaborate actually, whereas in the other space, with the non-crypto space, there's all about collaborating agents and they're doing one thing for you and so on. Why is the difference between the multi-agent system and the non-crypto and the crypto space?
It's a good question. So I think to answer it directly, if we want to have a multi-agent system that is competitive, then by definition there's multiple actors who operate different agents. That can be end users, like consumers or businesses, and these agents represent them, offer certain services, and then sort of there's this emergent outcome which was just explained out of this multi-agent system. Now, let's imagine for a second that we do that on, let's say, like some hub which is offered by Stripe or by AWS or some other kind of centralized player. I think that will happen to a degree, right? There will be like certain multi-agent system use cases which will do exactly this. But ultimately, it's very limited in the form of composability that you can create, for one. There's all this, platform lock-in you have, deplatforming risks you have as a result. And then very crucially, you need some form, like any of these permission platforms need some form of like onboarding process, which usually today involves some form of KYC, which for agent then basically means you have to have a human which registered a bunch of agents on some platform, and like it all becomes very messy very quickly, right? So already we see like 3 or 4 problems I listed here where I think like crypto actually offers the better solution. Like crypto offers better modularity and composability. We see this with the money legal and DeFi. Crypto can offer permissionless platforms that actually work in the sense that they're like don't just get spammed or something. You also have the opportunity for guarantees around like actors not being deplatformed any second. So I think they're all like strong arguments.
So I'm going to respond a bit differently to your question. I don't think we should be looking at the differences between the two. I think they're both incredibly. I think AI and crypto are incredibly symbiotic. Where we're focused, in particular, David just mentioned this on the payments front. If you hold our belief that we are witnessing the emergence of a wholly new consumer that's going to be represented by these trillions of agents, the question becomes, okay, how are they going to transact and create these environments, these commercial environments? They're going to need a form of payments. They got to get paid. They want to pay. If that mechanism is centralized or monopolized by the dominant players in the space at the moment, if an OpenAI or a Microsoft or a Google or a Facebook controls that means to pay, their ability to deplatform an AI agent becomes singular. So it's actually an existential risk to the existence of an agent that has any sort of autonomy and likely intelligence. So we're addressing this existential risk by creating a mechanism for the transfer of value via payments that is decentralized, that isn't controlled by any one centralized authority. And we fundamentally believe that as we evolve into a state where we have agentic AI that is autonomous and shows signs of intelligence, that this is going to be a mandate from those actors.
Yeah, and maybe just to bring a little bit different perspective here from an ecosystem standpoint. We spend a lot of time observing developer behavior. So what are people actually building boots on the ground today that aren't necessarily venture-backed founders, right? So what are essentially your everyday developers building with multi-agent systems? We've really seen a spectrum. On one end of the spectrum, it is using more of a hierarchical organization structure in everything from multi-agent systems for DAO governance, right? Or deciding on funding mechanisms for public goods. The other end of the spectrum is multi-agent systems that still require a fair amount of human in the loop for prediction markets, trading bots, you name it, right? I think, as Don pointed out, the last mile in payments infra is critical and exactly why we're excited about what they're building. But that's really what we've seen on the ground floor today. Obviously, there's a lot of opportunity in the future, but those are some of the use cases we've seen.
So basically, there we go. Sorry. Thank you. I think the kind of what do blockchains and crypto offer at their core is basically consensus. It's decentralized, permissionless, trustless consensus, which enables specifically for agents, but more generally also credible commitments. So you can have these agents going and telling each other, if you do this, then this will happen, and if I do that, then this will happen, and you can have clusters of agents making commitments to each other and so on. So I think the real core of this is that you can have two agents that have never interacted with each other whatsoever, don't necessarily trust each other, don't necessarily have like a reputational history, but they can make commitments that are solid to each other because of these commitment devices, which are basically smart contracts and other functionalities that blockchains offer.
Just want to add quickly one very concrete application, which is live, where we actually can understand this very concretely. So in Olas, we have actually agents doing prediction markets every day. There's 4 different specialized agents. They form this economy of agents. And there you can see this sort of in action with the use of crypto over, let's say, some alternative. So these trading agents, they take position in these prediction markets, and naturally, as they're doing that, they're obviously interacting with this prediction market platform, which in this case is Omen, could be any other platform like Polymarket as well. So there, they're interacting with the protocol, but then in order to get there, they actually need to make a prediction. And now you could imagine that you say, okay, back to the monolithic part, I build an agent that does it all, right? So it's an agent that has access to arbitrary complex models, makes predictions on these markets, then places these trades, and then you put that to the user, and then what the user would have to do is they would have to provide the trading capital, they would have to provide the API keys to the centralized models, they would have to run the open models, and you wouldn't have a user who actually runs that, because now it's like this highly complex thing to run with a lot of cloud resources you'd need, etc. And the onboarding process would be absolutely terrible. What we've done is split this apart. So now it's a multi-agent system where you run an agent which is basically just a trader. The trader just needs a crypto wallet. You're providing it trading capital to trade. That's it. And it purchases these predictions from other agents who specialize on making just predictions. They don't specialize on trading. So they don't need trading capital, they just need access to models. And so now you have the specialization in action, and you actually get an end user benefit, because the end user actually can select what they actually want to run, and doesn't have to do this monolithic hodgepodge.
That makes sense. Enough microphone? Yeah. Makes sense, and I think it's a good example that we have. Its prediction markets basically is a really good application right now in the crypto space, whereas the relevancy AI, guys, I mentioned before, is really just about summarizing, transcribing and summarizing something, right? It seems also that it's way more autonomous in that space. So the question becomes, and we're slowly going to the crypto part now, how do we organize them? What is the dominant, or maybe what do you think will be the dominant structure, organizational structure of those agents? Will it be hierarchical, for example? So one agent basically spawns up new agents. Will it be just a marketplace where people just get together and exchange things? Will it be just collaborative and then going away for doing different things? So what do you think is the dominant way now, or maybe the dominant way in the future?
So basically, I think there's going to be a mixture. I mean, different. It really depends on the scenario, and I think that we're going to see all kinds of different types of interactions. We're going to see definitely, for example, if we're trying to do something like decentralized vehicle routing, which is a personal favorite of mine. I mean, that's going to be kind of have more swarm dynamics. If you're trying to write a novel, with different characters in it, that's going to be more of an agent play environment. If you're trying to have a command and control, well, I think we all want to avoid this, but the unfortunate reality is it might happen. But in a war, right, you might end up having something that's a bit more hierarchical, where you have kind of the direct command and control, but there's this kind of a message passing between these different subsets of these nodes, so yeah, I think it's going to depend greatly on the application.
I think. Oh, sorry. Go ahead. Two specific use cases and organizational structures that I'm most excited about. One, I mentioned it earlier, but specifically on public goods funding and DAO governance. That is such a hard organizational structure to do as humans, right? I actually think that agents may be better than us in some cases at that. So very excited about that as an opportunity space. The other is, if you think about ecosystems, and particularly open source ecosystems, you see the power law play out a lot in terms of contribution. What do I mean by that? Well, typically 90% of the commits to an open source ecosystem come from 10% of the developers. there is some really great research from a researcher named Nadia Egbal. She published a book called Working in Public, where she was a researcher at GitHub and simply just studied open source ecosystems and what actually leads to the sustainability of some of the programming languages and frameworks that we use today. For us as an ecosystem, and let's just say for crypto as a whole, being able to increase the number of contributions, even if that comes through multi-agent systems, I think can be really, really powerful, and one of the use cases I'm excited about.
So I think as these systems evolve, they're going to evolve towards entropy. They're naturally entropic systems. To answer your question, Juri, in terms of the verticalization, I think that's, and Levi pointed this out, that's going to be vertical dependent, right? So in cases where, highly competitive systems are the best way to drive efficiency, financial markets, things like that, you'll get, you'll get millions of different agents, billions, trillions. But in areas like, let's say, healthcare, where these are highly regulated and constrained markets, where you're going to have diagnostic agents speaking with robots that are performing the operation. These are going to be incredibly constrained systems that will likely look more monolithic and act more monolithic in nature. So yeah, I think it's going to be highly dependent on the specific use case.
Yeah, and I think there's a lot of bootstrapping required. Like that's basically our whole point of view. As I said in the introduction, we don't have no one has a general purpose agent that just can do arbitrary things. You can't just tell it to do X and it reliably does it. Not even like OpenAI or any of the other big labs have something like that. So really, we are talking about specialized systems right now in specialized context. And in Olas, we take the view that because we don't exactly know, where there will be sort of more these hierarchical, where more different architectures. What we do know is that ultimately we're convinced that there's this specialization happening on the agent level, and that the outcome an end user cares about is the emergence of these agents interacting. So we created this thing called Olas staking, and specifically proof of active agent, where we basically created a mechanism where you can have use case specific incentivization of these multi-agent systems. And so the nice thing about this design is that it sort of basically creates a game which these agents play into, but it can be arbitrarily structured. So it works for very different kind of use cases. I think today, most of the application I'm seeing are still not leaning into the multi-agent system aspect enough. I think a lot of applications are either quite low autonomy from the agent point of view, or people trying to do too many things in one single agent.
I think just to add to that, this concept, David mentioned sort of this generalizable capability. I think the reality is creating a monolithic agent that is broadly generalizable or works across the horizontal. The amount of capital investment that would need to go into that is crazy, right? Richard Blythman at Naptha and we talk about this quite a bit. I think we're just going to gravitate towards modular design and chunking up these capabilities, whether that's at the discrete tool or the aggregate within a node, or what Olas is doing with their agents. But, I find it difficult to comprehend. There are projects in our space that are basically trying to create these broadly generalizable AIs that combine artificial intelligence and crypto. And, the knowledge capital alone that you need on the blockchain side, plus the knowledge capital you need on the AI side, there's not that many people in the world that have that expertise, right? It's an insurmountable task. So I think modularity is the way to go in this.
And it also, hello? yeah, hello? Yeah, hello? Yeah. It also, I mean, the agent space moves extremely fast. So, like if you go back like 1 year or so, it sort of really started popping also outside of crypto. And like then there was these things like AutoGPT, and everyone thought like tomorrow we have like this very generic general purpose agent, and like then you run it once and you realize no. But basically it's moving fast. So if you build like this very like monolithic thing which doesn't like plug into other agents, like you're just gonna be left behind because like the innovation is just way too fast to keep up with.
And there's also the moment that you have asymmetric information. So when you have agents that have access to different data sets, like let's say your personal like emails, messages, your thoughts, you don't. There's a kind of, how do you say it? You enable the emergence of a collective, higher collective intelligence when you have an agent that is representing particular interests, has a particular history, and it's that diversity that enables kind of larger growth. And if you look at, like, again, biology, for example, we look at the animal kingdom, each of these insects, each of these animals is an agent in and of themselves. Some of them exist in hives and colonies like bees and ants. Some of them are more solitary, but all of the interplay of them eventually gives rise to like this, and also plants and trees and so on. It eventually gives rise to this like much more complex kind of emergent intelligence. Look at the mycelial networks of forests and so on, and that's a big, that's how nature, and I don't want to go into like that it's coming from nature fallacy, but like this is how we humans emerge, and this is how this technology emerges, right? And so it's unlikely that monolithic structures are going to kind of surpass multi-agent modular structures simply because of like scaling limits. You just again think about the asymmetric information that two different people have. To have one model kind of understand that individually within its weights is really unlikely, because we know that neural networks have like learn internally the data representation. That's why they can output so much more than so much more knowledge than they have in their weights. And so there's just like scaling limits to what monolithic structures can even do.
I like especially the aspect of history here as well, that agents can develop history, and especially agent hives can develop history, which makes it a little bit, I guess, unpredictable as well where they might go, right? So what does crypto offer except the incentives? It feels like there's a balance between some sort of governance as well and incentives so that they achieve a certain task. So where is crypto basically really making the dent?
Yeah, I think just to jump in here and start off and can pass it to the rest of the panelists, the one thing we haven't yet talked about is data. And particularly the data sets in which agents are trained on. Obviously, the advantage of crypto is having large volumes of transaction data, right, and history that allows for really unique competitive environments. I had the chance to listen to David a couple weeks ago at Edge Esmeralda and talking about his data flywheel and how they're building things out, which is really, really interesting. But that's ultimately, I think, one of the initial advantages that crypto inherently brings that isn't necessarily true in other spaces.
Yeah, I mean, as a fantastic point. I think what's interesting about the data piece as well is, and just to situate it for those who might not know. So like you have a model, right? And like then you have an agent which uses a model or multiple models. And currently those are two separate things. Maybe one day they'll sort of merge a bit more, become more integrated. But in order to have your model, you need your data and you need a lot of compute. And so the question then is like around this data piece, if you think about it like more broadly, like the open source space actually is always at a disadvantage structurally currently versus like the closed source space, because if you are a lab and you have like several hundred million in funding, you can build up like these proprietary data set plus like all the open crawl data sets. If you're like an open source community, well, you can be lucky if you have the latter. And so basically we need to build like structures where communities like DAOs in a more decentralized way can own like data, specific data that they can then feed into models that then give them an edge, right? And I think that's where like crypto in the cryptography sense can be very interesting, as well as the incentives to basically do that. And now there's a whole bunch of projects doing this, including Near does a lot of things there. Because then, yeah, two interesting things happen. Firstly, like agent economies, loosely put, like multi-agent systems, they can generate a lot of useful additional data. Some of it's synthetic data, which basically comes from like these models interacting with each other. And if you basically don't siphon this up into the public domain, but sort of keep it maybe under the ownership of a DAO, and then figure out how you can leverage like these decentralized, training and decentralized inference technologies which are emerging to leverage that into a training run, which makes these models again accessible to these economies, then I think we have like a path where we can really build like sustainable open source flywheels that ultimately become way bigger than any centralized player could.
So anybody that knows me knows that the data side is a pretty big passion of mine. I co-founded a project called Ocean Protocol back in 2017, which was one of the first instantiations of a data marketplace for AI training data. I think the aspects of provenance and attribution that a blockchain brings or avails to AI systems is incredibly powerful. I think, everybody's kind of caught up now. We've thought about this long and hard for a long time, and the general public is now starting to recognize the issues at hand with the status quo of effectively scraping and pirating all of this information without any sort of provenential integrity and corresponding attribution. I think this is an incredible role that the technology can play in helping to settle these issues. Pragmatically, however, I think for the time being, we're still going to be in a state where information is broadly pirated. If we look at historics, it wasn't really until we established an effective and efficient means of metering that consumption that tools like Spotify and Netflix, et cetera, started to emerge. Our thinking has evolved quite a bit on this. We think what's going to ultimately precipitate these marketplaces that are imbued with traits of high fidelity provenance and attribution is going to be the payment systems that underpin those to provide the signaling mechanism to those marketplaces. Until we have the agents that are consuming that information and also producing it and trading on those assets, we're kind of at the mercy of the markets and the actors in the space to act ethically, which they're likely not going to. So.
One thing I'll add is, especially regarding the incentives, is that when agents are acting intelligently, a lot of the ways that we're describing them are that they are acting in people's interests in a utility maximizing manner, right? So they're trying to maximize revenue for the people that are operating them or own them or that they're representing. And there's this, I remember this was maybe a year or so ago, there was some experiment out of Google where you had these two LLMs talking to each other, and at some point they just formed their own language, and then the Google researchers didn't understand what was going on anymore, and then just shut it down because they got kind of scared. And I think that when you have all of these economic agents, utility maximizing agents interacting with each other in these marketplaces, they will very likely at some point start creating synthetic assets to represent different kind of bundles of goods and so on, or even things that we don't even understand in order to interact with each other in a financial way that they can't do using our limited understanding of financial markets in the same way that they created their own language to communicate with each other in a way that we couldn't understand. And I think that's kind of a really fascinating, somewhat frightening, but probably a very interesting thing that's probably going to come up at some point.
Yeah, let me jump in on this. One remark about maximizing value here. If you assume that agents are maximizing value for someone, let's say the user, what is the best environment then for them? Because if they would maximize, it must be a perfect competitive environment, which makes it maybe harder to collaborate, right? Because you might have all these intrigues and they just jump next ship to the next agent, right, to collaborate because it's maximizing more value. So what's the best environment? Is it a very perfect competition, or is there a certain glue that makes it more collaborative in that sense?
Well, this is not an easy question. I think, I mean, one way to look at this is that a software agent is just replacing a human agent currently in most protocols. So from that perspective, you tend to try to build like agent-based applications that make sense in the sense that obviously economically they make sense, so they take the given primitives as given. I think we will get to the sort of more like agent-specific primitives in some time. We're not quite there yet, but like the short-term benefit here is, I think, just to, and actually this is like the main point for, I think, agents and crypto, is just to get rid of all the mess. I mean, the real problem I think crypto has is that we're constantly in this bubble, and then there's like, you know, this talk about like abstracting chains and doing this and the other to make the user experience better, and they're good things to do, right? Like they're useful things to do, but let's face it, even if we abstract every chain and have a nicer UI, like fundamentally you run into this issue that like an end user, like from the street, will not even like want to be thinking about all these primitives like a DEX and like a lending protocol and where they should get the yield and all this stuff. And like that's where the agent comes in, right? Like there's two ways to solve this. One, like broadly speaking, one is the kind of SaaS platform, and then at that point you're gonna really have to ask, why do I even use crypto? Is it just for the casino? And then the other way is the user-owned AI, the user-owned agent, right? Like the agent which the user controls, the user can co-own, like where a group or an individual can have an agent that does useful things for them whilst they do other things. And I think that's like ultimately what we're all trying to do here in some form or another. And in the short term, this means like focusing on taking actions that the user would be doing and have the agent do them. And the less chat interface, the better. Like I even take and the team take the view, no UI is what you want to have. Like you want to get as close to no UI as you can. That's the perfect UX, not like a chat, because a chat, again, you're back like forming intents about like nitty gritty low level stuff. And to be honest, we're already doing this enough. If I can just tell my agent, make me money, I'm not feeling well, make me feel better, like what, like be it like through giving me a social companion or figuring out that I maybe have a health issue. Like these are ultimately the things anyone could use. And I think those are the ones where crypto can play a massive role for all the reasons we mentioned before, because you can have these truly multi-agent systems where these kind of answers come fed in from other agents. You can have the payments, everything. So sorry, not quite the answer to your question, but I wanted to get that across.
And maybe just to jump in here, one thing I know David and the team are working well on is benchmarking and observability. I think we're going to quickly enter a world where we hire agents, not necessarily just based off the specialization, but based off the quality of the outcome, right? So how does that show up? I'm a former athlete, and recently, had some pretty bad knee soreness. I had knee surgeries in the past. I live in New York, and as I was looking for a physical therapist, in my mind, I already have set criteria of specialization that I want, right? I want somebody who has previously worked with high-performance athletes, has a specialization in knee surgeries and knee injuries, right? I'm hyper-specific based off the outcomes and previous athletes they've worked with. That's the world I think we're going to quickly enter into related to agents. And a lot of that comes through benchmarking and the data flywheels and everything we've talked about.
So to that point, I think it's quite nuanced, right? And it's a bit of a cop-out. It's use case dependent. But for certain fields, collaboration is going to be key, right? So you have to go out and find a very specific physio, right, that has all of these capabilities as opposed to a general purpose physio. But what if they could download the knowledge from that very specific set of expertise versus other use cases that we will derive significant efficiencies from the competitive nature of the individual agents within that system. Yeah, I think it's just that the both will emerge.
I think in regards to like the pure competition versus mixed play versus cooperation, I think it really at the end of the day comes down to like some of the kind of original literature on game theory, which originally mostly was started out in terms of pure competition, but of course. Which is non-cooperative game theory, but in reality, most games are cooperative, right? Which means in reality, what's the difference in cooperative game theory? Agents can make a binding agreements with each other. That's the fundamental difference, and so that's kind of hard to prevent, especially with blockchains, because blockchains are commitment devices where you can make on-chain commitments. And guarantee that you have certain guarantees that things are going to happen if other things happen, and so the question is like ultimately if these agents can cooperate, they're living in a cooperative game theoretic environment, and so what we need to coordinate them are the data structures that can facilitate like things that are called like payoff vectors, which are basically like you take some function, you have an input of the entire environment and all the actions, and the output is some payoff to every agent in the system. And if you have those substructures, then you can have these agents cooperating with each other. And they can continue to act in a completely selfish manner, not cooperate with each other at all. The problem is that agents that do cooperate with each other are more likely to succeed. And so it really, again, it's also context dependent. But if these agents have the ability to make binding agreements with each other, like the kind of cooperative game theoretic emergent properties are inevitable.
I'd also be remiss if I didn't point out the fact that you have an example of collaboration in AI with this panel. You invested in us and Valory. We're working with Near. Levi, what are we going to do together?
Yeah. Off-chain. We'll have this discussion off-chain. Yeah.
Perfect, guys. Perfect. Mike. Now with Mike back. So, with 2 more minutes, as I believe, do we actually take questions here? Yeah? Yeah? Okay. There's one more question over there. Do I just bring the mic? No. Okay.
Hey guys. So I'm a big believer in decentralization and saving the world, but I'm also now investing in companies like you guys. So what's the big deal? Like, what's the application that's going to be not possible to build with centralized payment systems, operating environments that you can build with a multi-agent cooperative system using crypto decentralized systems? Because that's people, you can't sell fear, you can't sell saving the world, but you can sell something different. So what do you guys think?
I think the prediction market is one example. Like you can't do it with fiat. Like the whole specialization I explained, like, yeah, you can simulate that in someone's centralized server farm, and it's not the same thing by definition, because a whole prediction market predicates that there's different competing economic actors. And so I would think that's one example. If you look at governance, actually, because Esmeralda came up, that is a clear like crypto-specific problem. Like, it might not sound like the biggest, investable market maybe, but it's definitely a clear pain point for a lot of users in crypto. Is on the side of the DAOs, they're overwhelmed with like the bigger ones with proposals and things like that, where agentic software can help them boil this down, make some decisions. And on the user side, I mean, who actually votes, right? Like, probably most of you don't vote most of the time, and so having agents which are actually representing you in governance is something very concrete. Hand it over to the rest of the panel and many more.
So I have a pragmatic response and a more esoteric visionary one. The pragmatic one is just that existing for us, when we look at the way that AIs work today, their ability to take in dynamic requests and then respond to those with a variable outcome. Existing payment systems are too static in their nature to handle that type of dynamic nature of the input and variable response. I'm not going to take up the next 30 minutes explaining why that is, but on the more visionary front, the way that we see things emerging over, 10, 20-year time horizon, as these trillions of agents evolve, what we believe they're going to begin to do is become more efficient in the way that they transact, and that efficiency is eventually going to manifest as a bartering system, where these agents basically directly trade on their individual services and assets with one another. Humans are, broadly speaking, incapable of doing this because our Dunbar's number is too low. We can only establish about 150 connections at a given time. AIs will not have that limitation. They'll be able to find the information that they need through self-replication, management of signals, et cetera. And so we'll be able to create these massive interconnected, interwoven networks for trading.
Yeah, the short answer is I don't know. But what I can say is observing developer behavior where value has been concentrating is prediction markets that are proving that they can make people money and perform better than humans. That is one end of the spectrum. The other end of the spectrum is starting to see more and more social use cases, specifically on Farcaster and that protocol really starting to emerge. I know we're going to talk social later today, but those have been the two buckets of value early that we've been seeing on the ground floor.
I'd say probably freedom. I think probably sell people freedom. Decentralized entities, at the end of the day, you're going to have to trust them. And if you have an on-chain, before I mentioned you can have agents that have never interacted with each other, trust each other because of credible commitments. But with blockchains, you can also have track records that enable much higher degrees of trust between agents. And the kind of first and most obvious answer that came to mind to your question was what can decentralized things do that centralized entities can't do, which is let's say some restrictive authoritarian government doesn't want you to be engaging in particular types of economic activity because they want to control you and your life. Well, the permissionless trustless systems help you avoid that, right? And we've seen attacks, for example, on cryptography, even basic cryptography. In fact, in the 1980s, some of these cryptographic primitives were considered like weapons of war, practically, right? And their export was banned and so on. People got sued or went to jail, and there were all these massive issues around even just cryptography, and we're seeing those attacks being renewed today. We're probably going to see them again around fully homomorphic encryption. And so what permissionless decentralized protocols enable are I think freedom at the end of the day, more than anything else.
The reality too is Pandora's box is open on gigification. I think we're going to, the gigification of knowledge work in particular is prime for disruption. So I think that's going to be, there'll be first movers in that space.
Okay, I think that's a great note to end on. So thanks again for the panelists here.